Welcome to the 32 session of LMS for BSc Mathematics 5th paper. Title of the paper is Numerical Analysis. This is for the colleges or students which are studying under the Gulbarga University affiliated colleges. Right? The title of the chapter is Finite Differences, and under that we are going to solve the problems on forward differences. So, recap. In the previous section, we have understood the argument and entries. What do you mean by argument and entries? And we can able to define the forward difference. Now, at the end of this session, we can able to solve the problems on forward difference, and we are going to construct the forward difference table. So, I have taken the table here, that is x values and y values. They are arguments and entries for the forward difference table. We can see it here, that is x values are x0, x1, x2, x3 up to xn, and y0, y1, y2, y3 up to xn. Okay, to create the forward difference. I am going to now create a forward difference table by taking a particular some values. So you can see it here. The x consists of 6 entries: x0, x1, x2, x3, x4, x5, and y has y0, y1, y2, y3, y4 up to y4. There are totally 6 entries are there, we can say, right? So now we are going to construct a difference table, that is delta, first forward difference, delta square, second forward difference, delta cube, third forward difference, delta to the power of fourth order forward difference, and fifth order forward difference. So how it can be created? It's very easy to create, friends. So the subtraction of y1 minus y0, it will gives you the delta of y0, that is first forward difference of y0 is delta of y0. Here delta of y0 is nothing but an y1 minus y0. Okay. Similarly, if you make y2 minus y1, that is y2 minus y1, here it will gives you the delta of y1. Similarly, delta y3 minus y2, it will gives you the delta of y2. Similarly, if you make the difference of y4 minus y3, here it is y4 minus y3, it gives you the delta of y3. Similarly, if you go for y5 minus y4, y5 minus y4, it is here, it will gives you the delta of y4, right? So this is the first forward difference, that is delta. Similarly, I can go for delta square. How we can get is, if you make the difference of delta of y1 minus delta of y0, here it is delta of y1 minus delta of y0, it will gives you the second forward difference, delta square of y0. Similarly, if you make difference of this two, that is this two, that is delta of y2 minus delta of y1, right? It will gives you the delta square of y1, right? If you make the difference of delta of y3 minus delta of y2, here it is delta of y3 minus delta of y2, it will gives you the delta square of y2. Similarly, if you go for difference of delta of y4 minus delta of y3, delta of y4 minus delta of y3, here it is, you can see it here it is, right? If you make the difference of these two, we are going to get delta square of y3. You can observe here, friends, here it is y0, y1, y2, y3. It is with delta square, all are with delta square. Here all are with delta. As table goes on, as the difference table goes on, the number of elements are going to reduce, right? So here, similarly, we can make the difference of delta square of y1 minus delta square of y0. We can get delta of y0. Similarly, delta square of y2 minus delta square of y1, we can get delta cube of y1. Similarly, if you make the difference of delta square of y3 minus delta square of y2, here it is, we can get delta cube of y2. Similarly, if you make the difference of these two, this and this, that is delta cube of y1 minus delta square of y1, we are going to get delta to the power of 4 of y0. Similarly, if you make the difference of delta cube of y2 minus delta cube of y1, then we are going to get delta to the power of 4 of y1. Similarly, if you make the difference of delta to the power 4 of y1 minus delta to the power 4 of y0, we are going to get delta to the power of 5 of y0. This is the way where we can construct the forward difference, right? Now, next one, we will take an example and we will try to find the values of delta of f of 3, delta square of f of 1, delta cube of f of 1. The entries are here, x values are here, we can count, and f of x. After substituting this 0 here, we can get 1.0. Similarly, when x is substituted in the function, we are going to get 1.5, 2, 2.5. So these entries are there. You can see here differences, x 0 and 1. Just I will show you. So here you can see here the difference between this and this. It is 1. Difference between this and this, 1. Difference between this and this, 1. The difference between this and this, 1. Here all these ones are constant. They are called as my h. Right, friends? Okay. So now we have to find delta of f of 3, delta square of f of 1, and delta cube of f of 1. Right? Remember this. You'll find it now. Now you can see it here. We have constructed the forward difference table. It is here. We can say here the x values are here. Here it is x values are here. You can see it here. All these are x entries. 1, 0, 1, 2, 3, 4. And y's are whatever he has given. We have wrote it here. 1, 1.5, 2, 2.2, 3.1 and 4.6. Now we are going to find the first difference, forward difference, delta of f of x, right? That is, if you make the difference of 1.5 minus 1, that is, I'll write it here. The difference between these two, the difference between these two, the difference between these two, and difference between these two, right? The difference between these two. What will be the difference? 1.5 minus 1, 0.5. 2.2 minus 1.5, it is 0.7. 3.1 minus 2.2, 0.1. 4.6 minus 3.1, 1.5. Right? So this is delta of f of 0, delta of f of 1, delta of f of 2, delta of f of 3. Right? Similarly, if you make the difference of these two, that is 0.7 minus 0.5, we are going to get 0.7, sorry 0.2. If you make the difference of 0.9 and 0.7, we are going to get 0.2. If you make the difference of 1.5 minus 0.9, we are going to get 0.6, right? That is delta square f of 0, delta square of f of 1, delta square of f of 2, right? Similarly, if you make the difference of these two, that is 0.2 minus 0.2, it's 0. If you make the difference of 0.6 minus 0.2, it is 0.4, right? Now, here it is delta to the power of 4 is also there. So that is, if you make the difference of these two, that is 0.4 minus 0, it is 0.4. We know that the difference between these two. So we are going to get delta to the power 4 of y0. Right? So now our work is to construct the forward difference. We have constructed it. Now our target is to find the value of delta of f of 3. Where is delta? We can see here. Our delta is here. Here is my delta. Right? In that, which part I have to find? F of 3. F of 0, f of 1, f of 2 and f of 3. This is f of 3. Its value is 1.5. We are wrote it here. We can see it here. This is the 1.5 value. You can see this, right? So here it is 1.5 is here, right? So similarly, now next value, what we have to find the next value? What we have to find in the next? You'll see the question. So what is that they are asking? Delta square and delta cube of f of 1. Okay, so delta square means here it is. Delta square means here we can say here it is delta square. Delta square f of 1. You can see it. Second value. First one 0, second one is 1. Delta square of f of 1. Its value is 0.2. We can note down this one. That is similar way. Delta cube of f of 1 I have to write. Delta cube of f of 1. Delta cube of f of 1 is, you can see it here, it is 0.4. Right? So we can note down this. Now we can see that we are wrote it here. Right? So we are noted it here. We are noted it here 0.4 and 0.2. Right? We have noted it here. Right? Now, next thing is we have found the values of delta square of f of 1 and delta cube of f of 1. So here ends our problem. So some of the reference books for you friends, they are UG Mathematics for Numerical Analysis by Mante Swami and College Mathematics by Jairam, Shanti Narayan, and all the authors they have written it. So thank you friends.